We're going to go over a new concept that exists in C++ and it doesn't exist in Python. And when you're starting to learn C++ and you're going, for example, through some code online, some sort of repository, you are quite confused as to why there are files that have the same name, what are the different extensions, and in general, what does it mean to have all these files. Well, in C++, there is something that does not exist in Python, and that is called the header files. So we will have two files, and when we have larger projects, then we might have many different modules and many different files with a lot of functions. And at the end of the day, when they interact with one another, if we have any sort of collision between naming or anything like this, the program will not compile at all, and we will have a lot of errors. So in order to help ourselves debug, what we're going to do in C++ is have some sort of files, which are called header files. And generally they have the extension .h. In this situation, I will come and call this one my header, just to give an example as to how they are used. And generally they go hand in hand with at least one file, which is a C++ file, and it is it's called implementation file. The difference is that the header file just contains all the definitions, as I'm gonna show, all the declarations, all the functions that we're going to define, but without any actual content. So in the implementation file, which is the actual C++ file, which I will call my implementation.cpp, we're going to have all the logic, meaning this is where we're actually going to define everything. As an example, I'm going to come and say a little bit, for example, something very small. I'm going to call a namespace. This is something that does not exist in Python that much either. And that is because the namespace is again some sort of mindset that exists behind C++, that everything has a specific scope, and therefore when we say namespace, it's like we're discussing about we're organizing our code within a namespace, and we isolate everything that's going on in that namespace. So I will just come here and say that I will have I will use, in this situation, a dummy namespace, ns, and I will start and I will come and say that, for example, in this namespace, I want to have a class. I will come and say a class, and I'll say that it is my class in this situation, and it will have something inside that will be, for example, a method. A public method, because we do this difference in, we do clarify that in C++, and I will come over here and say something. For example, I want my class to be called something, sure, but I also need to define. So, for example, I need to come and say that it is an integer function. Like, what does this function return? What does this method return? In this situation, I don't want it to return anything. So there is this type sort of thing in C++, which is called void, which means that you can actually write functions that they do not actually return anything. And that's what I'm going to do here. The errors are because I haven't put any semicolons, so I will go and do that as well. In Python, after I made this structure, I would go in and actually write everything. For example, I would have to come in here in the void function, open, let's say, these curly things, and write all of my logic that comes with that comes with it. But we won't do that in that case. It might seem it might seem unnecessary to just go and start writing the implementation of this function somewhere else. But you will see that when you actually have much bigger files that they have to interact with one another, and since C++ is a statically typed language, a lot of problems will come along, a lot of debugging, so we might as well just go through with it and accept that this is how it's happening. That's how it's to do. So I will jump now on my implementation file, and how you include all these declarations that you have done over here is by adding it as a module, exactly as we will do in Python with import. For example, that is the Python one. In Python, I will just say import header, and I will be good. But this is not quite how you do it in C++. You go and have a hashtag include, which is basically the same thing. And in this case, because the myHeader .h is a header file that I have written myself, it specifically goes in quotation marks. I think that's how they're called. And I will start writing the actual implementation of everything that I have declared before. So I will start saying that I want to be in the scope of the namespace NS namespace as before. How I'm going to do that? I can use the keyword using namespace, and I will also finish with a semicolon, and then I will actually I want to have a main function. In Python, for example, we might have a main like this. That is exactly how I would have in here. And in order to make it into C++, I will come and say what I wanted to return. I wanted to return a 0 because that's what I want. So I wanted to return an integer. So I clarify what this function that I'm about to define returns. And then I will go and say what I wanted to have inside. So I'll just go with my curly brackets, come inside, and I want to create an object of what I called my class before, which I will call test class. And that will be totally fine if I wanted to do that. However, I need to say exactly what type it is. And in this situation, it is my class. That is how I initialize, as we saw yesterday, that you have to say always what the variables that you're using, like what type they are. I will also put a semicolon. So I have instantiated. I have instantiated a test class, and in order to call the public method, I will come and say exactly like in Python, test class dot something, and finish with a semicolon, and then of course write return 0, because that's what I want this function to return. So this is how we do that. And for example, if I wanted to add things add things to happen in general in my class, or to what exactly I want to be happening in here, I will just come here and write it again and write all the implementation. And we do that so that we can have this to avoid collisions. And it might seem a little bit counterproductive. Why do we have all these duplicated, let's say, files? But it's not actually duplicated. It is just this different mentality that one has to come from, coming from a Python background.